Welcome to 10.3. So here's a fun fact. If you go to 10.3 in the notes, I would say that 10.3 was the most complicated day just because there's a lot of interesting applications of similarity. But under the circumstances, all of the secondary 2 teachers decided, you know what, that is a big nice to know instead of a need to know. And so we changed it to actually just be the word problems, which you were going to see later in 10.5. We moved the word problems here. Now that is all of 10.3. So if you look on my screen, I wrote 10.3, formerly known as the last page of the notes. So that way, if you printed off the notes, you still have these examples. They're just on the very, very last page of the notes. Your joke of the day is, yesterday I parked in the C section of the parking lot. I had to climb out of the sunroof. That's pregnancy humor. Okay. All right. So last time we talked about, similarity and how it's all about scale factor, proportional sides, things like that. So here's the big idea here. With any word problem, I just want you to draw a picture. So I have a tree 24 feet tall, cast a shadow 12 feet long. Here's my tree, and here's its shadow. So I know this is going to be 24 feet high, and this is going to be 12 feet long. Brad, here's Brad. He is 6 feet tall. How long is his shadow? What I'm hoping you're seeing here is that we've just created 2 triangles. And if you remember, our conditions for similarity, they all have to have congruent angles. And all of the side lengths have to be proportional. The reason that these triangles are similar is because if I have the sun is casting a shadow at the same angle between the 2 objects. So between the tree and Brad, that angle is the same, and then both of these are right angles. And so because of that, we can say that they're similar triangles. But I think some of you, without even having me to explain, can figure out what is the length of Brad's shadow. Well, here's the first thing I see. To get from 24 to 6, what do? We divide by 4. So to get from 12 to our question mark, we're going to divide by 4. That means that we get a 3-foot shadow. And that's all it takes. Let's look at another example. Okay, more trees. Trees are good things. A tree with a height of 4 meters. So that's going to be 4 meters. Cast a shadow that is 15 meters long. So it's a bit of a longer shadow. So there's the triangle that's been created. How high is another tree that casts a shadow which is 20 meters long? Same deal. Except this time I don't see it quite as easily as I did, with the divide by 4. So with this one, we can, if I call this piece X, and if I don't know it off the top of my head, we can just set up that proportion. Remember, here are some corresponding sides. Here are some corresponding sides. So I can go 4 over X equals 15 over 20. It doesn't matter which way you set up the proportion as long as you're consistent in your direction between the triangles. So I went first to second for both of my fractions. And now I can cross multiply this. 4 times 20, which gets me 80, equals 15x. And now I can divide both sides by 15. And we type that in our calculator. 80 divided by 15 and I get 5.33. And so I know that this tree is going to be 5.33 meters tall. And that's pretty much all this lesson takes, is really at the end of the day, what you should be doing is drawing a picture. That is all this takes. We'll do one more example because this one's, oh look here, big idea. Draw a picture. This last example is just a slightly different variation. Okay, a girl, 160 centimeters tall. We'll give her some nice long hair. Okay, so she is 160 centimeters tall. She stands 360 centimeters from a lamppost. Make myself a nice little lamppost. You know, for someone with not much artistic ability, that's a pretty dang good lamppost. Okay, her shadow is 90 centimeters long. Well, if the light is in front of her, which way is her shadow going? Her shadow is going behind her. So this shadow is 90 centimeters. And we want to know how high is the lamppost. Okay, this one is a little bit more tricky because what's happened here is that I know your temptation is to say, oh look, 2 triangles. That one, remember the only reason the other ones were similar was because of the sun and the angle of the light creating that same angle. See, the sun was a fixed point, and so the angle on the shadows is going to be the same. So the angle on shadow here has to be coming from that same light source. So if I do it this way, I want you to see that I actually have a triangle within a triangle, which means I have 2 separate triangles. So I'm just going to draw that as my 2 separate triangles. I have 90 centimeters and 160. And then for my big one, I'm trying to find this height. Well, to get the big one, I have to add the 90 and the 360, which would come together to be 450. And now I can do the same thing. If you can see the scale factor, by all means go ahead and use the scale factor. Or if you want to set up a proportion, you can set up a proportion. I personally see the 90, and I know to get to 450, I got to times it by 5. And so I'm going to take the 160 and do the same thing and times it by 5. And I think that's like 800 maybe? I'm going to type it in my calculator to make sure. 160 times 5. Oh, look, 800 centimeters. If you weren't sure about that scale factor, remember you could always set up that proportion. 160 over x equals 90 over 450 and cross multiply that way. But honestly, I know that is all the information that you're going to need for this 10.3 assignment and quiz.